Here I'm going to explain how to do a stoichiometry problem. Now remember, stoichiometry is just the process of converting from one thing to another, like how many tablespoons are in a cup, or how many pints of milk do I have if I have 3 gallons. It's the same thing. So in this lesson, when I refer to A, I'm referring to some sort of substance, A, and its quantity, and I'm trying to convert into a different substance, let's say B, and a new quantity. So basically, I will see how many grams I make with how many grams I use. Here is a roadmap. This roadmap, as I call it, will give us a general structure of one of the longest stoichiometry problems we'll have to do in our class. Now you will notice that in this stoichiometry problem example roadmap thing, I have some sort of ingredient that is given A, and then here is A again. But notice here in this step that this is where A turns into B. So this is kind of where the magic happens. This is where we have the way to convert from one set of ingredients A to another set of ingredients, let's say B. And then of course you can see on the right hand side here, we have B again. Note that the two steps with the letter G in it, which stands for grams, are the two steps that we refer to as the steps that need the molar mass. And of course the molar mass you can always find by looking on the periodic table. And here in the middle we have what is known as the mole ratio. And the mole ratio is where we can convert from moles A and moles B. And remember, for that step we need to look at the balanced equation, and we use the coefficients in the balanced equation to plug into these spots here. So you would use the coefficient for the given and plug it in here, and you would use the coefficient for the type of elements that we're looking for, and you would plug it in there. Note that for here in this spot, we always have a 1 because that's molar mass, and in this spot, we always have a 1 because that's molar mass. But notice that it is upside down. More on that in just a second. So here we have an example where I want to convert 10 grams of oxygen, now the given, to grams of H2O, which is what we want to find. So from grams of O2 to grams of H2O. And in my directions here, number 1, I say write the given, and I'm referring to writing the only number in the question that we have, which in this case would be 10 grams of O2. So that is therefore the given. Okay, so we'll work on an example later, but that's the given. Step 2, we write times line, which is pretty self-explanatory. Step 3, when I say cancel units, you can see in the example I provided that you are literally dividing grams of O2 by grams of O2, which essentially cancels it. And then we need to put something up here in order to move forward with the problem. Now I will give you 2 choices when it comes to molar mass and 1 choice when it comes to mole ratio. See if you can guess which one goes in that blank space. Molar mass can come in 1 mole A over grams A, written kind of like this, or grams B over moles B. Now keep in mind, of course, that we're still dealing with the given, so that should be 1 clue. And also, in order to cancel grams of O2, we put grams of O2 on the bottom, and this expression here happens to have grams on the bottom. So we copy the expression, but replacing A with O2, so we have grams of O2 on the bottom and 1 mole of O2 on the top. So there's my molar mass. Molar mass for O2, looking at the periodic table, is 32 grams per mole, but it is upside down. In other words, I am saying 1 mole of O2 for every 32 grams of O2, which means the same thing, and also allows us to cancel oxygen. So then what is the next step? Note that now we have another thing that we can use called the mole ratio, and that is what we're going to need to keep continuing with the problem. So we'll just go ahead and move down here, and I'll show you how to use that mole ratio. Continuing along, we see that we have to cancel. And now we have 2 options for going up here. We can go to grams, but then we'd have to go from moles O2 to grams H2O, and that's a big no-no because in the mole ratio is the only place I can go from A ingredient to B ingredient, and here I've gone from mole A ingredient to gram B ingredient, and that's nowhere in any of my directions. So I cannot put grams up there at this time. I would have to use mole H2O, and that shows us that we've gone from moles of one ingredient to moles of another ingredient as specified in the mole ratio. We continue along by canceling as usual and then asking ourselves the question, should we use the mole ratio again or use the molar mass? Well, we've already switched from one ingredient to another here in the mole ratio, so maybe perhaps we could try our luck with grams of BH2O on the top. And if we're going to use this molar mass, remember it's always 1 on the bottom, and then we look on the periodic table for the molar mass of H2O, which is 18.0 grams. The last thing would be to look at the balanced equation and note that there must be a 1 for the O2 because there's a 1 in the balanced equation, and a 2 for the moles H2O because there's a 2 in the balanced equation. Now we can multiply across the top and get 360, multiply across the bottom and get 32, and our answer is 11.25. Keeping in mind that if you want to take a shortcut, you can just enter in your calculator 10 times 1 times 2 times 18 divided by 32 divided by 1 divided by 1, and you'll get the same answer. Don't forget your units, which in this case we have grams of H2O left behind. And last but not least, the wonderful box to show our answer. So once again, keep in mind that we canceled, ended up with grams of H2O, and calculated 11.25 grams of H2O. And in this example, my O2 was my A ingredient. I went from A to B, which was H2O. B was my H2O ingredient, using the mole ratio, and then went back from moles of B to grams of H2O using my molar mass step. Now, what if we wanted to change the problem a little bit? Here I have changed the word grams of H2O to moles of H2O, and from 10 grams of O2 to 10 moles of O2, and let's see how this changes everything. As usual, I start with the given, cancel by putting moles of O2 on the bottom, and now I have to ask myself the question, what should go on top? Here are your choices, and some of them we know we can't use, like we can't use that one, and so we basically want to compare whether we should go moles of B or grams of B. If we go to grams here on top, it would have to be O2, and that's not what we want in the problem. We're asking for how many moles of H2O. Yes, we did cancel those things. However, we went in the wrong direction. Now we have grams of O2. We don't want that. So we try moles of H2O, cancel, and see that we end up with exactly what we want. How many moles of H2O? Our balanced equation magically appears, and again we see that we need 1 for moles of O2, 2 for moles of H2O. The answer ends up being 20 moles of H2O, and then we have a box. And that's all. Good luck on the next problem.